The Bechele project. Why servo calibration? PWM stands for Pulse Width Modulation. Model servos receive their position information via a PWM signal where the relation in between on and off of the PWM signal defines the servo position. This on and off relation is also called duty cycle. Servos typically have their minimum and maximum limit position in a timing range of 50 and 3000 microseconds. With a PWM frequency of 50 Hz, these are 20,000 microseconds duty time, the range of the possible duty cycle is about 20% of the available time. When the servo gets a signal beyond these 20%, the result is unpredictable. In best case, the servo does not react at all to out-of-range signals. In worst case, the servo gets damaged when the motor tries to continue moving beyond the internal mechanical limit of the servo. Servo calibration makes sure the PWM signal will be adapted to the servo type. In a east sense, the joystick delivers a value range of 0 to 4096. A ready calibrated servo always takes a value range of 0 to 4096. The calibration maps the range of 4096 steps to the allowed movement way of the servo within its mechanical limits of the model you drive. This means, independent of the movements in rotation degrees, a ready mapped servo takes 4096 steps from one limit to the opposite, no matter if the servo can physically only turn for 5 degrees or 360 degrees. To make the calibration a little easier, the calibration is divided into two steps. First is the type-dependent servo movement range. For a type of servo hardware, this is usually always the same. For example, a SG90 can turn for about 180 degrees, so the servo type limit values are the same for all SG90 servos from the same manufacturer. The second is the movement range of a servo within its function in a model. This implies that typically the second calibration is often different for different servo functions within the model. If you ignore calibration, it probably will happen that whether the movement does not reach the limits of the model or it exceeds the limits, which often burns the servo when it tries to move further, but it runs against the mechanical block. So servo calibration is an extremely important thing. A well-calibrated servo list in config LPM keeps you from bad fault experiences. Calibration has a second huge advantage. Imagine you use servo type A for a mouth movement where the rotation of the servo is mechanically limited to 30 degrees. You then teach your model so you have a big number of play sequences where you spend hours and hours of work. Now your servo breaks and you have to replace it with servo type B, or you want to change the mouth mechanics so it opens now for 60 degrees. Without calibration, this would mean you had to reteach all your sequences again. With calibration, you don't need to do much. You just do a new servo calibration and your existing play sequences run flawlessly without any change. Note, take enough time to accurately calibrate. This pays itself back 100 times.